All right. So when we open a new Blender file, it looks like this. So just to kind of orient you to where we are, your sort of functional controls are here. This is modifiers and scene stuff. Here's for your object collection, and this is where items will be. If you have here, this is where some of the tools are. Blender is a deep well of tools. Luckily, there are searches in the various sections, so if you get lost, sometimes you can use the search bar at the top to try to find what you're looking for in the number of settings. But I will admit, sometimes if you click on something wrong, you end up in a place that gets a little confusing. So if that happens to you, don't worry. It happens to everybody. um, so by default, your screen will probably look more like this. I start in edit mode because I edited my base file at one point. So in your new file, the first thing you can do is get rid of the basic cube. So I'm just going to go ahead and get rid of that. And the second thing you're going to want to do that I've already done to my Blender is have this on your bottom bar. So when you're working in Blender, one of the easiest ways to see your faces, vertices, and things like that is over in this bottom thing, which can give you basically what they call scene statistics. So to turn on scene statistics, you want to go to Edit, Preferences, and then under Preferences, you'll go to your interface, status bar, and check scene statistics. You can see if it's unchecked, there's nothing there. If I check it, things go back. And that sets up your scene statistics. So that's just go to Edit, Preferences, make sure you are in the interface, status bar, scene statistics. I really think that should be turned on by default, but that's not how Blender works. All right, so now that we've got that, we want to get our 3D model, and this goes with the assumption that you've downloaded a 3D model from Printables or Thingiverse, something like that, and that you know what the model you're going to want to work with. And I'm going to go slow so that if you want to work alongside me on your model and just pause, that you should be able to do that, though you'll have to listen to me take some time explaining things from here and there. So I'm going to load in my model, so I'm going to go to File, Import, STL. Now, most time you'll be getting STL files if you're getting ones that are intended for 3D printing, which is really what this is aimed at describing, is how to take those high poly 3D printing models and convert them down. So once again, that's just File, Import, STL. All right, so I'll go to my Downloads folder, and I'm going to pull my Crotaloo left on base and bring it in. Now, you may wonder, where is it? It's nowhere to be seen because it's over there. All right. So you may notice when you're downloading models that are intended for 3D printing, they often are not aligned with this space, which is called the origin in Blender. That is because when models are going through their final passes for 3D printing, oftentimes they are going through those final passes on the print bed in terms of in slicer software, and that slicer software is orienting the model with the location on the print bed, not the location in like a 3D space like this. So the origin of the print bed is not the same as, say, the origin of Blender. So to fix that, we're just going to make sure our model is selected, and then we are going to select Object and set origin. So Object set origin to center of mass or volume. It really doesn't matter. We're just trying to get it relatively in the center of the model to make it easier to work with. So I do that. And then over here under the transform options, we can reposition it. We can also reposition by using the move function over here and sliding it around. I find it easier just to set the origin to the center of the mass and then change your X and Y to 0. That way you know it's dead in the center and you're good. It's also a little quicker than moving it around. So once we've done that, so we've centered our object to the origin, now we are going to apply it. So we're going to go to Object Apply, All Transforms. Now this is an important practice when we're working because this applying those transforms, if you're scaling, adjusting size and things like that, will affect things like your normal maps, your displacements. So if you're over here and looking at the transform for the object you've selected, these should all be zeros and these should all be ones. If they are not, you will likely have problems when you're working with your model and applying UVs and normal maps. Okay, so that is sort of getting us centered and ready to go. All right, so now that we've got our model centered, let's talk a little bit about these 3D models that are intended for printing. So when we think about 3D printing, we want everything on the model, all the details in the direct surface, which means they have to exist on this mesh for it to print. So if we look at this in the wireframe mode, and sorry, let me take off the X-ray vision, we can see just the number of shear facets that we're looking at. So every detail in the scales is captured, little undertucks, things across some of there's some large areas there's some areas with large faces, but the most part it is extremely detailed. We definitely don't want that because we don't need that many faces. As you saw, you just need a low poly model for the normal map to abstract from. We can also see in our back corner where we've done the scene statistics that this is almost a 200,000 face model. That is absolutely not going to work for TaleWeaver, so we need to fix it. So before we start breaking down our facets, we need to make sure we do a little bit of cleanup to make sure that this model is ready to be broken down. Now, the first thing we need to do is get rid of this base. It's unnecessary, and we definitely need to make sure it's not there. Some models that you download might not have a base, but some of them will. So this, I think, is a good thing to know how to do. All right, so to remove the base, we're going to select our model, and we're going to edit mode. So that's just here. From this dongle, you go from Edit, Object Scope. We'll talk about some of these, but we're going to just go right into Edit mode. Now, from Edit mode, we want to select our entire model. To do that, you can go up here and hit Select and All, but we're going to be doing this a lot. So you'll want to learn to just hit A on your keyboard. When you hit A on your keyboard, your whole model will light up. It's all selected, which is a little bit easier than tabbing around. So with your whole model selected, we want to bisect it. So to bisect our model, we go to Mesh and Bisect. Now, bisect cuts a model in half, essentially. When you're looking at bisect, it is almost impossible to get it aligned straight. So if you're looking at getting a flat geometry, you're just not going to do it by hand. So otherwise, I just pick a random spot to slice through and go from there. Now, everything you want to do in the bisect tool, don't click down. Once you click down, the bisect has occurred, and you can see those cut lines. So you can use Control-Z to back out of it and go back to here. Once you use the bisect tool, instead of committing it by clicking on your workspace, you want to go here at the bottom. There's the bisect options, and you can expand them. When we're bisecting, the plane point determines where the bisect sort of center is. Plane and normal determines the angle. So when I'm working, I typically set the plane point X and Y to 0, especially if I'm cutting along the Z axis. And now the Z will determine how far up and down that cut occurs. Plane normal is the angles. So I typically set these to 0, 0, and 1. And now we can see that this shape is aligned with the center of the origin of the workspace and pointing directly upward with no angle. So I'm touching the workspace, but I'm not clicking on it. So this is a middle mouse click, which allows me to sort of rotate my camera around. And I can manually grab the arrow and then move it around. I find this to be a little dangerous because I'm likely to click on the workspace and have to start over. So I don't like to do it that way. So I wouldn't advise it. Instead, I would advise figuring out where you want your cut to be and just typing it here. So if I go to 1, that's going to put it 1 up. If I go to 0.5, 5 up, etc. I'm familiar with this model, so I think the best place is going to be 0.01 because I think I did this model. Oh, no, not quite. 0.1. So basically, I'm trying to capture it without this. An easier way to see that is to have these checked. So clear outer clears everything on the inner direction of your arrow. Clear inner clears everything on the other side. So I'm wording that perhaps incorrectly, inside being the way the arrow is not pointing, outside being the way the arrow is pointing. The arrow points to the outside, as you like, but truth be told, just click on the other one. You've got a 50-50 chance of getting it right, and then you can swap it. You also want to make sure fill is selected. Fill is going to fill in the areas that have been cut. So if you don't have fill, you end up with these open holes in your model. So you want to make sure to hit fill. And let's see if I can adjust that down just a touch, 8, because I want to get as much in the feed in there as I can. Oops, wrong direction. 0.08. Let's see if I can trim it a little bit more. 0.06, maybe? Ooh, but I think 0.05 actually did not contain it. 0.02. So we're getting really on the wire there. So we'll just do 0.05 and call it. We're talking such a tiny amount that it doesn't matter. All right, so then I click on the workspace to commit the cut. All right, so now we have a spare part that we don't need, which is this ring. You may have this happen with other circumstances, which is why I like to show it if you're cutting off part of a model, or maybe your model has multiple parts that aren't in use, then you might end up having to remove something. So to do this, you just select any part of it, and you can do that by sort of clicking and dragging it over when you have your select tool chosen. So this select box is the top option there. Just grab part of it and then go to select all. Oh, nope. Grab your select box and go to select linked. Linked. So what this is doing is selecting every face that is linked to these, and so that selects everything. Another method is to grab part of it. And if you have a keyboard with a numpad, you hold down Control and hit the plus on your numpad and see that it slowly adds each of the parts in sequence. This is helpful when you're doing other things in Blender, and plus it's fun to watch, so I like it. But it is a little bit slower, and you can get the same by doing it the other way. So just select part of it, and then select linked, linked. And then delete key on your keyboard, which you'll notice doesn't delete it automatically. It brings up a window to ask you what kind of delete do you want. In this case, because we're deleting everything, it doesn't really matter which of these three we choose. I'll just choose faces, so the faces go away. If we were to choose, so if I do that again, vertices, it'll still all go away. And if we were to choose the edges, it would still all go away because it's really encompassing everything. There's circumstances where you might not do it that way, but in this case, it's fine. All right, so now we'll go back to object mode. So just go here to object mode, and now we have our model separate and ready to go. So I'm going to take a moment to stop talking about the process to talk about normals. So when we're discussing normals in Blender, there's sort of two things. We talk about normals, we talk about the normal map. Now, every face has a normal. So when we're looking in wireframe mode, sorry, not invisible mode, but wireframes, and we're looking at, sorry, not X-ray, all of these different faces, Blender has to know for each face which is the inside and which is the outside. So that if you're inside the model, it knows for purposes of lighting and structure what is where. This is also important in 3D printing because it has to, there's still some determinations there. It's a little more forgiving. But regardless, especially for what we're going to be doing in the digital space, is we need to be able to know what's inside and what's outside. So to give you an example of what that looks like from Blender's perspective, when we have just a base model, is we can do this. So here are our viewport overlays. So one thing you'll notice is you've got this lovely grid behind your model. If you click this, the grid goes away. So if you lose your grid, and you're very confused as to why, no, it's probably because you clicked this viewport overlay. The other viewport overlay options, there's actually quite a few. You can add statistics here as well. I think it feels more cluttered than the other corner, but you could technically add it there. The other piece is face orientation. Now, I'm going to turn this on, and it's a bit garish. So this is face orientation. So this bright blue indicates this is the exterior of my model. The red, which is very garish, indicates it assumes this is the inside of my model. So what it's doing is it's showing me sort of the normals, the normal orientation of each face. This is important when we're troubleshooting, because if we are evaluating a model and looking for holes or invalid faces, we would see a red flash on the surface. So if you're wondering why is it so horribly garish when you go inside your model in this sort of view, well, that's because you need to be able to see it. There are ways to sort of detect some of these things in a more automated way, but they're imperfect, and it's just easier to spot things with the human eye sometimes. So there is that piece of normals. Now this differs from the normal map. So I'll show the other scene again. All right. So in this sort of setup, remember we were talking about normals. I'm going to go back into just the solid overlay. So on this guy, we're going to do the same thing. Let's view those normals. So we see what we would expect to see on all of these guys. Now this differs from the normal map. I think I touched on that briefly earlier, but let's go back here. And this is what the normal map adds. And we can see what that is by going into the shading tab. And I'm going to go to, which of these materials is that? I think it's that one, that one, that one, that one. Okay, so if I click on this, actually, let's just do this so you can see it a little better. All right, so that's what the normal map looks like. So if you're wondering how this all actually looks, this is basically saying for each part of the model, you can kind of get an idea that this is like a topographic sort of map. And these different colors and things represent different topologies. Well, these are the topologies that the 3D sort of software, when it's rendering them, will then apply those topologies. So it knows the face orientation, so it knows where to apply the topology, which side of the object to apply it to. So the normals are not just the faces, but also the normal map, which dictates sort of the topology of those faces when it's rendered. So that's probably the best way to explain that. So it's face orientation, which is just the normals of the faces themselves, and then the face topology, which is how the normal map gets added in. So you may be wondering, why is this important to know? Well, in truth, it might not be. It's important to know because when it's a problem with your normals. But knowing how the normal map fits in, I think, is helpful for myself. But in terms of this piece and being able to show that face orientation, unless you have a problem that you're not able to troubleshoot, you're trying to figure something out, you probably will not need to ever turn that view on. So I'd say don't worry about it, but it's good to be aware of it. So our next step is going to really depend on how we want to approach the workflow. There's two branches of this workflow. One is the sort of a fast and loose branching where we don't do any corrections to our base model, we just go with it. And truth be told, I think that wet method is probably going to work, honestly, almost all the time. I'm also going to show a meticulous method for making sure you're doing a lot of detailed cleanup. The second method is probably useful if you want to use these skills in other things, or if you just like enjoying doing cleanup, which seems like a weird thing, but I think about video games like people play like Power Wash Simulator, and there's just something darn relaxing to them. Well, Cleanup Mesh Simulator is right here for you if you feel like participating. So we'll talk a little bit about what I'll refer to now, I think, as Cleanup Mesh Simulator, but otherwise you really won't need to worry about it. I'm going to go forward with what I call the fast and loose method for preparing our models, and this is going to go through what will seem much quicker than the other version, but we'll go through it slowly to explain the steps, way of getting your model TaleSpire ready in probably about an hour. The fast and loose method may or may not work for your model. It'll depend on how clean your model is, how much detail you want. But if you are just wanting to get something together for game, a model that you're not going to use a lot, maybe some minions or something like that, you don't need to spend a lot of time unless you just do it because you love it. So pick what works for you. I'm going to save this file because apparently I haven't saved my working file. So we're going to call this version the code blue left. And then I'm going to save a branch of it because I know that as I'm working, I want to keep it separate. So we'll do a save as fast and loose. We'll call it the FAL version, which hopefully will not represent failing at anything, but we'll go for it. All right, so fast and loose method is really simple. We're not going to mess with our high mesh. We're just going to say, hey, that's my high mesh. I'm leaving it alone. So we're going to take this. I will make a copy of it just so I have my original mesh available. And we'll call this one the high poly. And then we're going to make another copy of it. I'm going to call it the low poly. All right. That. So now we have, and just so you know what I did, I used a lot of keyboard shortcuts. That was a Control-C, Control-V to make a copy. You can also do just right-click, copy, right-click, paste. So if you don't do a lot of keyboard shortcuts, that's your best bet. All right, so now we've got our original, a high poly, and a low poly model. So now we'll hide the other ones. We don't want to see our original. We don't want to see our high poly. We just want to see what we're going to make into our low poly. And I'll give you 2 hints here. One, when we're making a low poly version, details don't matter. If we were to take this and just start decimating, we'd have some problems. So if I take this and I go to decimate, and we'll start with just a planar decimate because that shows you some generalizations, we are not reducing the face count very much. So we went from, what is that, almost a 200,000 face count. We cut it in half. We're on about 100,000 face count. But part of the problem is that it is still accounting for all of these details. But we know those aren't necessary. We know that those are going to be part of our normal map. So if you have textures like scales, fur, things like that that are low relief textures, you can hammer them out in sculpting. So I'm going to get rid of this modifier because I don't want to do the low poly decimations yet. And instead, I'm going to go to sculpt mode. So basically, think about it like low relief, I can't think of another term for that in sculpture, but basically low relief sculpting, like the face of a coin. Well, if you're looking at a normal map, everything on the face of the coin would be part of your normal map. The only thing to be your mesh would be the flat cylinder of the coin. So if you have things that are like that are defining details of the surface, but aren't actually a projected part of the surface in any real sense, they can be removed. So we are going to get rid of all the scales. To do this, we're going to go and just use one simple tool in sculpt mode. So we'll go to sculpt mode, which opens up this window. The next thing we want to do is select our smoothing tool. So you have a lot of tools over here. A lot of them are very fun. You can make all kinds of fun things with them. That's how I do my 3D modeling. The only tool we're worried about is the smoothing tool, maybe the flatten tool, but I'd say use the smoothing tool. You can adjust the strength of the tool from very light to where it does almost nothing, to very strong, where it really hammers things out. And you can adjust the radius to be really big, which we don't want, or really small, which you may want for detail areas. Other thing we can do is adjust things like the stroke and fall off, but for now, we're going to leave this as the defaults because the defaults are pretty darn good. So I might lower the strength just a little bit, just because one thing that can happen while you're doing this is you can end up kind of editing the shape of your model incidentally. So if I go here and my strength is really high and I start editing this guy, now it looks okay, but if I do it too much, you'll notice that I'm smoothing the front. This starts being a very straight when the actual neck has a lot of bow to it. We want to preserve those basic shapes as we're moving along. So we want to be kind of soft in our approach a little bit, just so that we get it without overdoing it. So I'm going to go and just sort of take out the scales. And take out any, just really try to get that surface nice and soft. Other things I can do is these edges of the bedroll. I can sort of smooth those out. Because those are sort of flat surfaces that really just have that as a relief on them. Now what I want to do here is think about when I'm painting to sort of preserve some of the lines that might be helpful as guidance for when I'm doing my colors. So that's why I'm not fussing too much with the sort of the saddle details. I'm trying to stay just a little bit back from those. Now, in terms of navigation, I haven't explained navigating around Blender because I've been focusing on these other aspects, but as I'm doing this, I'll kind of explain a bit. If I hold down Control, I can, if I hold down my middle mouse key, I can rotate my camera. So that's what all this is. If I hold down Shift and drag, that moves this where my camera is around in space. So middle mouse middle mouse drag with Shift. So the middle mouse key is kind of essential to what I'm doing here. Middle mouse drag, and then scrolling in and out with the middle mouse. So your middle mouse, if you have a middle mouse button, is essentially your navigation tool in Blender. If you don't have a middle mouse button, then I would say look up a video on how to navigate Blender without a middle mouse button. I think it's a lot of maybe hitting Alts and Shifts and other things that I'm not as familiar with, so I can't tell you how to do that. But if you have a middle mouse, that is how you do it. Now, I'll touch on some things that I'm aware of with this model that can be problematic. I know that when people are making 3D models and they have parts on them, such as clothes, straps, saddles in this case, a lot of times those are separate objects that are sculpted separately and then added on to the model. So in this case, like I sculpted the saddle and sculpted this bedroll and then merged the models afterwards. And that's fine. But what can happen when you do that is there can be odd gaps that get created. And I'll show you what that looks like in a second after I do a little extra smoothing here. Don't want to forget the shoulders. I actually chose this model because I feel like it has a decent amount of complexity in terms of mistakes that we can play with when we do Mesh Cleanup Simulator. It's got things that be elements of clothing that you might see on a clothed model or a humanoid model. And it has some animalistic characteristics that I think make it a good choice for this. So let's see here. What do I got? The tail a bit more. Go and smooth out the tail. Smooth out. I don't need that musculature lines. So now that I've done a lot of smoothing and I'm relatively satisfied, there's certain questions you may have, like, well, why not smooth out this shape? I think I'll keep it. It's not a huge, oh, I forgot the whole head. It's not a big issue with deep relief. I'm mainly trying to just get some of these limiters down. Face, like I want to keep the crease that's for the eyes. But a lot of this other stuff is gonna just add a bit. All right. That's looking like it's going to be a lot easier for the Decimate to interpret what it needs to do. All right, so when I'm talking about these combined areas, I just want to show you some of the issues you might see that we're going to ignore for the fast and loose method, but we're seeing interior shapes. So when I connected the saddle to the crow, you'll notice there's these interior cuts right here, or right here, where we have this space isn't useful in any way. It doesn't contribute to the model. It's essentially an invisible hole that runs through the model from here and comes out the other side, and it's unnecessary. There's also cases along the base right at this strap where there's a hole that goes right through the model there and there. Now, these are, we're just going to go with it in the fast and loose method, but if you notice things like this and they bother you, just know that they bother me too, which is why I might do some model cleanup simulator. But like I said, in truth, we'll look at the results of both the fast and loose method and the tedious method, or the simulator method, and we'll see that they're roughly going to give us the same results. So now with our smoothed model, let's actually try to decimate it. To decimate, we will go back into object mode. we are going to add a modifier. So modifiers are under this little wrench icon here off to the side. To add a modifier, it's just right here. So if you're clicked somewhere else for some reason and it doesn't look like this, just click on the little wrench icon and go to add modifier and decimate. So you have a lot of options here. Just I really actually probably only use 5 of these on any given day, but if you go add modifier, decimate, which is going to be under the generate the generate ones, and do that. By default, it uses a collapse decimation, which basically says, hey, for each facet, collapse it in on itself by whatever ratio you've selected. We're going to start with Planar Decimate. I like Planar Decimate because I find that it does a very clean decimation for these purposes and leaves us with a lot of detail. So if I go to Planar Decimation, by default, it's decimating at 5 degrees. Now, if I were to take that off entirely, right now we have roughly 200,000 faces, so 186,000. If I do a Planar Decimation at 5%, it drops us down to 43. So it takes off about a quarter. It takes us down to almost a quarter of our faces. What I want to do is actually up this because we can see this looks like the same model. There's pretty much no detail lost. So let's actually up that a bit. Let's go up to a 7. Now that puts us down to 31, and we still don't see any significant, truly significant loss. Now we'll gain back some of these faces when we triangulate because planar decimation, leaves our wireframe like this. Each of these faces will need to be triangulated. So it's just giving us sort of these general swaths, but it does do a lot of reduction and takes out a lot of those details. So I'm going to go back to my regular view without the wireframe, and I'm going to apply that. Now, we can't really apply the planar decimation more than once or twice because it doesn't do anything beyond what it's done at a certain point. It's removed faces based off their angle. It can't make them have less angles than it has. So after we've done a planar decimate and feel comfortable with it, we really need to go to collapse. So I believe in iterative decimations, which means you never go straight down. Like if you want to do a ratio of 0.1, or sorry, I think it's what are we looking at, 10%, or sorry, yeah, 0.1, it's in small percent. I find that if I go to that right off the bat, it's not as clean as if I were to take it down in small portions. So if I go to like a 0.6 and accept it, and then rather than decimate the original model once, it's decimating the model and then decimating that model and then decimating that model. And I like to get my face count under 20,000 for purposes of TaleWeaver. So now I'm down to 10. And the other thing isn't just getting the faces down, it's getting the faces down and your model still looks good. If your model still looks good and you have your faces down a lot, feel free to keep decimating it. That just will make things easier for TaleWeaver and easier when it's trying to do its rendering. That, to me, actually looks pretty darn good. So that's 6K faces. Now, our face count is going to go up a bit when we make sure everything's triangulated. So if we go here, we can see it really needs to be triangulated. So to do that, triangulating the faces is simple. We're going to go into edit mode again. We're going to grab our entire model with A, and under the faces, we will go to triangulate faces. And see what that's done is it's taken each of the faces, if I Control Z, and it's made them into real geometries with triangles. So taking like this face here, and if I face triangulate faces, and it's made it an actual geometric form. So that looks pretty darn good. It pushed our faces back up a little bit. So let's go back to object mode, try and grab it. And we're at almost 10K faces, but that's still not bad. You may notice something though. We have a lot of these little stray lines on our model right now. We also have a lot of places where the light is cutting across it, like right here on the neck, things like that. If we look at this in wireframe view, we might notice that there's it's like a narrow triangle at an angle that maybe doesn't feel great. We want to clean those up as well. So we're going to do a little bit of mesh cleanup. Now, this mesh cleanup will be not the same as our full-on clean up all the things mesh cleanup. This will still be the fast and loose method. So we've decimated, we've gone in, we've triangulated. Let's go back into edit mode for some cleanup. So we can see we have little bitty stray vertices running around on the surface here. So like this little bit here, there's some weird oddities right here where things are not necessarily real spaces, like this little patchwork here. When it's decimating, maybe it had trouble figuring out how to handle the geometries because of maybe there was a flaw in the original model. It really doesn't matter. These are pretty easy to get rid of using sort of two key components. One is merge by distance, and the other one is clean up loose. So for example, this edge here, I'm going to guess is a loose edge because it's just sort of hanging out like a little line by itself, not pointing to anywhere. It's just kind of hanging out in space like that. It's not contributing to our model. I think if we left them there, it just might cause some detail problems later. I don't like them, so we're just going to get rid of them. It doesn't take any effort to do so. So select your whole model with A, go to Mesh, Clean Up, Delete Loose, and it's gone. So what this is doing is saying, hey, any piece of the geometry that's not part of a shape, just get rid of it. It's not attached to anything. It's not useful. Please just get rid of it. So that's easy enough. The next one is a little more tricky, and it's called merge by distance. And it'll say something like, okay, this area and these vertices. Well, these two vertices could maybe just be one thing. Maybe this, like all of this really could just be a single point. There's no reason for this patchwork to have occurred. So we can do something called merge by distance. Now this one gets a little dangerous because it can make some mistakes occur in your model as well. But for our purposes, let's just see if it'll solve our problems of a little bit of cleanup. And you don't necessarily have to identify these problems. You can just do the steps. But I'm going to select my whole model, and I'm going to go to Mesh, Cleanup, Merge by Distance. And by default, you'll notice that merge by distance is set to be extremely low. This is because normally you don't want to get rid of that many things, but since we're making a super low poly model, we can say maybe 0.05. And we see how it got rid of quite a number of these. So let's try 0.1. And then it gets rid of them. So basically I'm saying, hey, we don't care about some of those tiny little detail spaces, just really merge those together because those details aren't important in my low poly model. And it's true, they're not. So that gets rid of them. So now in case we created more loose, we're going to select the model again, clean up, delete loose. We see there's at least one loose that was left over. I think I saw it hanging out over here. And everything else looks weird in places, but really fine. That's a legitimate geometry, and I think otherwise our model is pretty good to go. The only thing I might be fussy about are these triangles. So if I pick face, see how this is catching the light in a very strange way? It's creating like a weird hard edge out when it really should just be flat. There's an easy way to solve that, and the best way to identify them is by how light is hitting your model. So you see that light hits the model funny there, and here on the neck. These are pretty big regions. Obviously the low poly model is going to make some things look funky anyway, but I can tell that hard edge serves me no purpose and I don't like it there. So I'm just going to pop over into sculpt mode and tap it down. And just tap it down a little bit. Now you don't want to do this too much because you can create some issues, but if you just know that if you just barely touch a few things, maybe you can correct them. There we go. Feel a little better about that. There. And perfect. We'll go with that. So yes, there's facets. Yes, it's choppy, but I'm not seeing these really hard lines on spaces that are otherwise fairly clean. So that's that. So now we're going to go back into object mode, and we are ready to make our cage. All right, so as I said before, this is still the fast and loose method of doing cleanup. We have created our low poly model from our high poly model. We've done some minor cleanup to it. Now we're going to create a cage. So we're going to make a copy, and we're going to paste it, or Control-C, Control-V, and we're going to call this one low poly cage. We want to hide our low poly model and reveal our high poly model, and see that they roughly align. Now you'll notice here was something I mentioned earlier. This curve isn't bowing out nearly as much as it used to. This is going to cause some problems when we're making our cage, because our cage has to encapsulate the high poly model completely, but we don't want it to be we want to encapsulate the model completely, but we don't want it to be too big. So when we're making our cage, we just want to make sure we account for that and are sort of cautious about it. If our low poly model is roughly the same as our cage, it wouldn't be an issue. So we can fix that in two ways. I'm going to fix it in sort of the fast and loose method, which means basically we're going to create the cage and we're going to adjust the polys of the cage. Rather than correcting the low poly model, we're just going to kind of work it moving forward. So to do this, we have the low poly cage selected, and we're going to go into edit mode. Now when in edit mode, you're going to use the shrink and fatten tool. You might not see it. It might be somewhere down here, or you might have it up here depending on how your bar is set up, but you're looking for the one that looks like a little cross grid thing, and it's kind of pinkish. If you don't see it, you can always use Alt-S. Click on your model, click on your low poly cage, and hit Alt-S. Right. Or I don't have the whole thing selected. Click on your model, have the whole thing selected, and hit Alt-S, and you can get your super fluff going. Now, we don't want a marshmallow, we just want a cage. So we want it just to barely cover up the high poly model, like that. Now, as I move my mouse, it moves up and down, but you want to get it to where it just covers it like this. Now, you'll notice I am not covering it completely. That's a problem. So what I could do is I can maybe make it just a little more fluffy. I call this the floofy version. I might Alt-S and just fluff it, maybe it's a teensy bit more. But I don't want it to lose shape. Like, I don't want it to start getting all warped and twisted. I want it to still retain quite a bit of its shape. So if I notice that I still have these odd sections sticking through, like in this case, this is sticking through, and it looks like maybe I moved that triangle in the wrong way. That's interesting. So there's an error in my model. I have a really weird triangle going into the interior there. So let's step back and just look at it. So I can't tell by looking at it normally, but if you look at the model, this triangle is a little confused. So we have some odd shape there that is definitely affecting the way it is able to shrink and fatten. So that's why when I was doing that cleanup earlier, you saw that there were some things I had to clean up so it would behave. So how do we fix this? Well, I'm going to fix it quickly, but the problem is we have to fix it on both. If you for your low poly cage to work, it has to exactly match your low poly model in terms of faces and things like that. So I'm going to delete my cage, open my model, see this funk, and decide to fix it by clicking on it, and we're going to go into edit mode. Now in edit mode, right now I've got faces selected. This is edges, this is vertices. With the vertices option selected, I see that I've got this vertices controlling these edges, and this vertices controlling these edges. I want these vertices to just be one, to sort of get rid of this. So treat these as if it's a single vertices. To do that, I can just click one, control click the other so that both are selected, and then right click, merge vertices at center. So now, this is a bit weird because it's a star part of the model, but it still will work. I shouldn't have that funkiness where all those weird non-appropriate triangles were hanging out. So, or you can also, so right click, merge vertices at center, or you can also hit the M on your keyboard and merge at center. Merging is helpful to be able to do. You can manually merge things and they work pretty well. All right, so that's fixed. Go back to object mode, and we'll create that low poly cage again. And hide our model. Have just the cage selected. Reveal our high poly model. With our low poly cage selected, go into edit mode. Select the entire model with A. I want to look at the faces, so I hit that instead of vertices, edges, faces. Hit Alt S to sort of do the shrink and fatten. And we can see now we can mostly get our model covered. Like I said, we want to floof it, but not floof it so much it becomes a fluffy marshmallow. Just enough to cover the base high mesh. Now you'll notice I'm not covering it completely. That's a problem. I might floof it a little bit more because I don't want to have to hunt and peck. But I know that the neck is flatter, so I'll have to make those corrections. But let's Alt S and just poof it a little bit. All right, and that covered the problems on there. And the only problem areas I have are this knee and the neck, probably because when I was smoothing them out, I smoothed them a little too much. To fix this, I'm going to select the vertices, and I'm going to grab one. Now, when we're doing this, I can take a vertices, and I can just grab it and move it. But I want to be cautious in how I do this. So you can turn on something, I believe it's called proportional editing. Now what this does is it means, hey, if we're moving this one, move the others around it just a little bit. Now, you won't see that yet because you have to kind of do some controls with it. But if I grab this, you'll notice there's this gray circle. Now, if I scroll out with my middle mouse wheel, you'll notice that it starts moving a larger section with it to cover it up. And if I go down, it moves just a little bit. So I'm going to pull that up just a little bit. So we're here. That way, I'm not disfiguring the mesh like in one spot. I'm, well, disfiguring it all together. And the same thing can be true here. So when I bring this out, I want to kind of have the whole mesh go with it. And you'll notice that if a poly gets, especially in an area like this, if parts get left behind, it negatively impacts the surface of the model. But all right, so that looks pretty good. So you've still got some weird things going on in the neck. This is what happens when you do a lot of remeshing, or not remeshing, a lot of this sort of editing. But like I said, we're not going to over perfect it because I'm trying to show that you don't have to do that. So I'm going to resist my instincts to go in and fuss, and we're going to let that just be it. So the only ones we corrected were places where the high poly model was sticking through our low poly model, and we also made a correction where this face was not pulling away with the model the way everything else was. All right, so now we have our high poly model, our low poly model, and our floofy little cage. So with those objects created and our low poly model back in view, we can start doing the shading to create the normal map. All right, so to create the shading for the normal map, there's two things we want to do. First, we want to apply smooth shading to our model. To do that, we're going to select the model, right-click, Shade Smooth. And now we see the model become sort of a gummy version. There's also the option of Shade Auto Smooth, which holds a lot of details. You may find that this does not look good, or that it does look good. In this case, I think it looks darn good. Now, here's what I don't know. I haven't tested with how this will appear in TaleWeaver. So I'm just going to try this in live because it's something that's easy to change. So you may see me do these steps again. So with the Shade Smooth option on our model, we're going to go into UV editing. So along the top, we've got different sort of views: modeling, layout, modeling, sculpting, UV editing, texture paint. We want to go to UV editing. In UV editing, we'll see our model in edit mode by default and something blank over here. To make our UV mesh, this is again the fast and loose method. There's a tighter method which we'll do in the other video. But we're just going to grab our model with A to select it all, UV, not unwrap, sorry, UV, Smart UV project, and OK. And we'll see that it is Now, one thing you may wonder is, what if I don't see UV? Because maybe your space is set up something like this or something, and you're missing options here. You can always scoot this over or scoot this over so you can see all the options and just sort of spread your windows around. So that way you have everything available to you. We'll see that it has taken our model and done its best effort to flatten it out. Now you'll also notice there's a lot of single face and two face sort of planes along the side, because it wasn't quite sure how to best unfold the model. But other things are unfolded along sort of logical lines. So this looks like it's probably part of a leg. That's obviously the back. This looks like it's maybe part of the leg or the underside of the tail. And some of it starts to make a little bit of sense. I'm not too worried about this. I'm going to make one change though. So if we do A, we've got our UV unwrap. I'm going to make one small change. So I'm going to go Smart UV project. And I want to give just a slight island margin. And I mean slight. So we're going to do 0.01. Okay. Now that is obviously, the problem with this is resolution. When we're doing our texture paint, we want to use this space as wisely as possible, meaning that we want things to be as close to each other so that when we're painting, we don't lose a lot of detail on our textures. So this means most of our space is white space. We don't want that. So let's go to UV, Smart UV project, and let's change that to point. Let's make that a 10 power. And say OK. Oh, see how this does. All right, so now we've got, maybe it's a little too little of a border between things. Let's maybe try a little bit higher than that. UV Smart UV project. So that's like 5. It's a little better. Try a little less. 0.025. Okay. So you can see how we've made some changes there, but now not everything is right on top of itself. This will not be the easiest model to paint. We're going to ignore what's over here and focus over here, but we'll talk about that as we go into painting. And you can play with these settings a bit, but I find that what we've got is pretty good. So you're going to use UV Smart UV project, and you might give yourself a little bit of an island margin, but not much. Probably the 0.02 is enough. So we'll leave that as is. All right, so without further fussing, we're going to leave this behind. We've created our UV map. Now we're going to go into shading. All right, so going into shading is just our 2 stops over on our top bar and go to shading. Now, this is a bit cluttered, so I like to get this bar here because we're not going to be using the space much, and this over a little bit. You want to have a good amount of room here. You want to create a material to represent your object. So here we're going to create new. So this symbol here that is the sphere that's been divided into hemispheres is the sort of symbol for materials. So hit new, and this is a new material. Don't panic. There are a lot of things that go on here for procedural generation. There's just a lot of really cool stuff. We won't need to use almost any of it. We're going to focus on just some very simple things. This is basically a simple shader, and the output of the shader basically saying, hey, put this on this object. So for example, right now it has some default settings attached to the shader that are just say, hey, apply this to this object. For example, the base color. So I could change the base color to be something else, and maybe I will just for sake of looking at the object. And now when I go into other views like layout, it doesn't change here, but when I go into the shader material preview, we can see it with the materials attached. So this is a way we'll start looking at things when we're previewing them and trying to see how things look together. So going back into shading, because that's where we were, we really didn't change. You don't need to change the base color. I'm just using that to illustrate what's going on. We want to create our normal. So I'm going to rename this material because I might want to reference it later. We're going to call this the normal fake. And you'll understand why. And you, as you're saving your file, you might be like, oh, I want to reference this setup later because I had it right and I don't know how I did it last time. And I'll even open my own old files to be like, wait, how did I set that up? And do that. So I'm going to call this material normal bake because I'm using it to bake the normal. Next thing we want to do is get it to make an image. So in this space here, click on it, right click, and go to add. So when you add, you can search through all of these different things to find it, or you can search. And I'm going to search for image, image texture. And it gives it to you like a widget, and you can just drop it in. So if you missed that, it's click on the space, because if you've got this selected and you right click, you'll get things for that node. If you click on this space, then you right click, you have adding. So add, in this case, it could be texture, image texture, or just search for the word image. And it puts it under your hand and you can set it down. Now I don't want two of these, so I'm going to delete one and stick with this one. So before we set up the properties for our bake, we want to make sure we actually have an image here. Right now, this is an image node with nothing attached to it. We want to create a new image here. And basically, it'll say, hey, Blender, make an image for me. So we're going to call it new. I'm going to name this Protoloo normal. And by default, it is going to be 1024 pixels. I believe, if I'm correct, TaleWeaver will accept 1024 or the double of that, which is 2048. And then you can use that if you want to use a higher resolution. For the normal, this should be fine. So I'm just going to leave it as the default. All right, so now we're going to get ready to bake our normal. So we've told Blender what we want it to save our normal as. We have an unattached image node, which is what we'll end up baking into. So we want to set up our properties. So this is going to be under the render properties, which is this one that looks sort of like a camera. So we're going to change a few things here. One is the render engine. It's defaulted to Eevee. We cannot bake in Eevee. We have to be in cycles to do any baking. Now, baking basically says, hey, create an image from everything that we've specified down here. So we want to do this with cycles. Under this, there's a few other things we want to change, and there are a lot of options. If you get lost, you can search for options in the top. But for now, we're going to hide sampling so you can kind of see they're all just categories, and we're going to go into the category of bake, and we're going to unfold it. When we're baking, the bake type is a lot of different things, but what we want is the normal. So it's going to know it's baking the normal. So bake normal. Now it's like, okay, tell me how you want your normal baked and what I'm using to create this thing. So for this, we're going to go to this arrow that is not unfolded, that's selected to active. So we check selected to active because we have a model we want to sort of dictate our normal, and we select cage because we're using a cage method. And under cage, we're going to select our high poly model. And this is basically saying, I'm sorry, I did that wrong. We're going to select the cage because we're telling it what we want our cage to be, not the high poly model. So we're going to do selected to active cage and select the cage. Selected to active means we will be selecting our high poly model, which I'll show you here. But the settings we've changed render engine to cycles. We've changed bake type to normal. We've checked selected to active. We've checked cage, and we've selected our cage object as the one that was our floofy version, that's the cage. So now we want to have our high poly model showing, selected, and then hold down Control and select our low poly model. This is that selected to active thing. So it's selecting your high poly, Control click, select your low poly model. Now you'll notice we haven't shown much of this window because we don't use it for very much, but we can see that our models are sticking in and out of each other. That is fine. That lets us know we've selected the right way. So now we just hit bake. All right, and that is exactly what we want to see. So over here, we're able to see some of the details, and this is nice because we can see this is the underside of the tail. We can see this is the side of the tail, and the other side of the tail. Now, a lot of this won't make as much sense because we did a fast and loose cut, so we have a lot of these little tiny bits off to the side, but that's okay. It's still a good normal map, and it's exactly what we want. Now, just to test our normal map and make sure we see it as we want, it's how we like it, we can make a new material. So this is optional. You can just say, I trust this image. I'm going with it. Now, if you're like me and you want to understand things as you're moving along, I suggest making another material for this. And to do that, I'm just going to make a copy of my normal bake using this little copy button. So I copy it, and I'm going to rename this normal preview. This lets me kind of see what's going on. And now I'm going to take this image over here, which we've already baked, and I'm going to add another node. So click on the blank space, add, and we're going to search for the word map. And we're looking for our normal map. There we go. And we're going to connect our color there, and then normal to the normal. So color to color, normal to normal, using a normal map node, which will translate this image as a normal map onto our object. Now, I know it's not going to look right when we first look at it, but let's see what it looks like. So if I go to Layout, I'm going to hide my high poly model, and now I'm still looking at it in the view I would expect to see it look right, and it looks janky. It looks very janky. Now, this is because of the color space, and there's a lot of details here. And you may see this when you import something into TaleWeaver, and you're like, wait, that doesn't look right at all. TaleWeaver has a button to correct it. Blender does not. So I'll show you, it's basically a matter of it telling each other what they want. So back under the shading, you'll notice you have some options under this image in terms of color space, linear, flat, etc., and the map. So what we're going to do is save this image so we can make some adjustments here. So to save our image, we go over here to where the image preview is, and we're going to click this box, which is like your options, image, save as. We can leave it at the default settings. The only thing I'm going to do is turn off the compression. So Crudlu normal, I'm going to say this is the left one because I've got several Crudlus. And this. All right, so when I saved it, it's now held in sort of my computer's memory and not Blender's memory, which allows me to make some changes here. I'm going to change the color space from sRGB to linear. And now when I go into the layout view, we can see that the normal map has been applied to our model. All right, so before we go any further, I want to make sure that this is going to work in TaleWeaver. So I might say, okay, that looks good, but I'm a little concerned maybe all these steps aren't going to work out like I'd hoped. Something's going to be funky. I want to see it in TaleWeaver, and I don't want to wait around anymore. I want to see what it looks like. So what I might do is just go ahead and export it. So we already saved our normal map because we had to save it so that we could apply it in Blender. Now we just need to save our mesh. So with only our mesh selected and nothing else, we can go to File, Export, and export it as a wavefront object. When we do this, we have a lot of options. We want to make sure we're exporting only the selected object. Everything else we can leave the same. So if these aren't your default settings, just know it's limited to selection only with your object selected. UV coordinates, normals, you definitely want to export those from the geometry and leave this all else as is. And I'm going to export that wavefront object. All right, now hopping back into TaleWeaver where we were talking about the default model earlier, we're going to import our Crodlu. So I'm just going to make sure I'm not into the examples folder. And obviously I've been playing around in this version a bit, but let's go ahead and import. So go to Assets, Import New Asset. I'm going to go import the Crodlu left normal and the Crodlu left FAL object. I didn't rename it, it's just the name of that Blender file. And I'm going to import them. Now, it takes it a second. Hopefully it won't crash while I'm recording. Good. Now, I'm going to go ahead and unselect all of these just so that I don't have to worry about them. All right. And then I am going to select what's now the default mesh, which I believe is this guy here. And we can see he came in beautifully with that smooth shading. So that makes me happy that that was successful. Remember I mentioned that I hadn't tried it that way before I did this recording, and oh, it's so lovely. I love it. So then we're going to add our normal texture just to see if it's working as we would expect. Now, I have several normal textures here for the Crowed Blue, and I want to make sure which one is it. One is it? I think that's the one I did. Now, you'll notice it's all janky, very similar to the jank that we had when we were looking at it in Blender. Don't worry about it. It has to do with the sRGB color space, which we were able to correct in Blender. This will also correct it. So let's go ahead and change the texture issues. And look, it is beautiful. And we have our Crowdloo imported. Now you may notice there's a little bit of pixelation. If we had used a higher resolution normal file, maybe that would solve some of that. But for now, like I said, this is just trying to get a quick method done. Now we've got our Crowdloo. We have him imported with a normal map. He looks great. Now our big concerns are color and perhaps this metallic AO roughness texture or PBR.